Hi guys, and welcome to this video on relations, domain and range, part of a Methods 1 and 2 series of videos over here in Australia. Don't stop the video, please. If you are from another country, don't worry about it. This stuff is critically important and in all areas of mathematics. Now, I am Darren, otherwise known as the MaffsGuru, and you are? Well, you can't introduce yourself to me like this, but if you want to, hey, leave a message below and say hi. Always good to know that you're watching. Otherwise, you can click the thing that the red arrow is pointing to, basically asking you to subscribe. I sit in the room talking to myself. It's weird. I think I'm going mad. And knowing that people out there are actually watching this is really, really important to me. So clicking that is greatly appreciated. If not, wait. Watch the video and click at the end. But please, please click. Now, as I grow smaller and the background goes darker, you will see that we're dealing with relations, domain, and range. And I love this stuff. It is critical to pretty much everything we do in maths from now on in the methods course, the methods 3 and 4 course, all of it. Now, by the end of this, we're going to need you to know what an ordered pair is, not an ordered paid. I have no idea what's going on there. I had a bit of a typo. Know what it means by relation, domain, range, interval notation, and how to write a relation in set notation as well. Now, this is following on from a video I recorded literally 5 minutes ago. It'll upload, and if you haven't already watched it, please, please, please watch it. Interval notation and all of the language we use in this course is really important. Spend an hour learning it and you will save 200 hours actually stopping being confused, really. Sets and interval notation are so, so important. So if you haven't watched the previous video, here's a quick one on interval notation. If we had the value that x is greater than or equal to 3, if you remember, we can write that with a square bracket, 3, infinity, and a curvy bracket. Now, why is it the curvy bracket? Because infinity is a construct. It's an idea. It's not an actual number. You can't ever get to infinity, which is why when I say infinity plus 1, it just doesn't make any sense. All right, so anytime you see an infinity, you have to do a curved bracket. What about if I had x is less than 10, for example? Well, in that situation, I would go all the way down to minus infinity, because minus infinity is definitely less than 10, up to 10. Is it including 10? No, it's a curved bracket, and minus infinity is a curved bracket as well. If I wanted to do the numbers between minus 1, x, and 10, and let's do both of those with the equal signs, then there would be a square bracket minus 1, comma 10, with a square bracket. Now, the numbers are always ordered lowest on the left and highest on the right. It's so important. So many people make silly mistakes by putting the numbers the wrong way around, but those brackets are what's critically important. Now, that was a really brief recap before we move on to some new language. And once again, Barry, why do you do this to Australia? Why do you do this to the world? What is your thought process in creating random words? Ordered pair. What's an ordered pair? Here's an ordered pair. 0, 4, 2, 6, 10 minus 3. An ordered pair is otherwise known as, oh yes, a coordinate. Why couldn't we just keep it as a coordinate, Barry? Why did we have to call it an ordered pair? I'm sure there's a reason in your head, but yep, half of Australia are like, whatever. Now again, where will the next time be that you see the words ordered pair? Undoubtedly an exam. You'll do it now, probably never see it again. Why are they going to put it in the exam? Because you'll have forgotten, and it will throw you. It will trick you, because you'll sit there going, well, what's an ordered pair? I don't know what an ordered pair is. I don't remember it. And it is just trying to confuse you. And a relation, well, I've got relations. I've got my mum, my dad, my sister. I've got, well, I suppose 0 is a bit of a relation, but not in this situation. And it's certainly not a relationship. We're not even going there, thank you very much. But a relation, here's a relation, y equals x squared. Here's another relation, y equals 3x minus 2. Here's another relation, y equals x cubed minus 2x squared plus x plus 4. What's a relation? It's a way of linking x and y values together. Now again, it doesn't have to be x and y's. It can be any letters at all. But what we're saying is, I can provide a value of x, and by doing something to it, I get a value of y out. So it's like an input-output machine. I plonk in a value of x, something happens inside and out spits a value of y. That's a relation. Now, with that covered, we can actually move on to probably the most exciting stuff here. Domain and range. Whenever I teach this, at the start of year 12, I generally get, I don't know, about 6 or 7 kids in any group of 20 who'll go, do you know what, I never really got domain and range last year. Don't say that. Please, again, whatever you do, please make sure that you understand domain and range. What is domain and range? I'm going to shortcut to this section here. Domain is basically X values which are possible to go into a relation. All right. Now, again, I'll say that again. Possible X values that can be placed into, I said an equation here. Bearing in mind an equation and a relation are the same thing. You're going to say, well, can't all X values go in? Maybe, maybe not. And the range is the Y values that are created from the X values you put in. And that's really important. They are the Y values which are created from the X values you put in. So if we go back to this example here, Y equals X squared plus 1. Here is my graph. Here is a sketch of Y equals X squared plus 1. We know what that looks like. But are you aware we are the ones who choose the X values? Now we're way past the days where we ask you to plot these things. We'd say X equals 0, work it out. X equals 1, work it out. X equals 2, work it out. We don't need to do that anymore. But we know that it's the X values that drive the Y values. The X values create those Y values. So I can't explain anymore other than doing some examples here. So making the screen just a little bit bigger so this all fits on. Here is a graph of Y equals X squared. So the domain are my X values. So my domain looks at what values of X seem possible from that graph, or more importantly, are there any values of X which we cannot put into that equation? Well, hopefully not. I can actually put in all the values from minus infinity to infinity, and I can square them, and I'm going to get out a value. My calculator's not going to explode, it's not going to melt, it's not going to turn around and laugh at me. I can put all of those values in. So my domain basically has all possible X values. Well, let's think about that. So everything from minus infinity to infinity can go into this. Okay, so I could write my domain as, don't get the brackets wrong, MaffsGuru, minus infinity to infinity, and there we go. Yay! That's one way of writing my domain. I could write it as all real values, because we know that from minus infinity to infinity is all real values. But again, we have to be accurate. We've got to be correct with the way we write this. And so our domain is X values are in and either minus infinity to infinity, or X is in real. So that X is basically saying to the examiner, I know this is domain, and the E symbol says it's in, and we've got that range of values. So there's my domain. But what about my range? Now again, remember, these are the Y values that are created from my X values. So what is the lowest Y value you see there? Well, hopefully the bottom of that graph is at 0. And where does it go to? Well, because I've got no other reason to assume otherwise, it goes on to infinity and beyond. And so it goes to infinity. And so my range now in this situation would be 0 to infinity. Notice the square bracket for the 0, because I can get 0 out. When I put X as 0 in, Y comes out as 0. So a 0 is a possible value. But again, we would probably need to write this as Y is in the set of 0 to infinity. Yes? Or we can write this as Y is in the set of positive real values or 0. So lots of different ways. Now you're probably going to sit there and go, well, which one's the most correct? Well, basically any of those except probably that and that. If you want to write domain equals and range equals, yeah, okay, some examiners may get a bit upset. Probably better off to do X and Y's, or when we get to the next section, function notation. Here's another one. Now, apologies, this actually doesn't say 1. Let's just change that to the value of 2, and I'll change this on the printed notes that you can download from MaffsGuru.com. Here we go, here's another graph, Y equals X squared plus 1. So what is my domain? What are my possible X values? Although the graph has shifted up, my X values, there don't seem to be any values there that can't be squared and then had 2 added to. So my domain, exactly the same as my previous graph. X is in, so what did we say? Minus infinity to infinity, or we could write X is in all real values. So easy. My range though has definitely changed. Again, look at my lowest value of Y. Here's my lowest value of Y. Seems to hit and go through the number 2. And so in this situation, my range is Y is in, my lowest value was 2, And once again, it appears to go to infinity and beyond. Yep. Is there another way of writing the range? Sadly not. Nope, we can't write R plus and squiggles and miss out the number 0 to 1. It wouldn't make any sense. You could, but it wouldn't make any sense. This situation here is absolutely perfect. Now, just when you thought it was safe to get into the water, yes, out comes a graph you haven't actually met before. And that's no big deal. Don't worry about it. The point of it is, any graph should be able to be looked at and you should be able to work out the domain and range. So, my domain, we're now looking for possible x values that can go into the graph of y equals the square root of x. Now, do you notice the fact that the graph doesn't seem to have anything there? Well, that's because you can't square root a negative value. So in this situation here, what do you think my domain is? Well, what's the lowest value of x that can go into that? Well, it would appear that my domain is given by the lowest value is 0. And what is my highest value? Well, this appears to be going on to infinity and beyond. So once again, there we go. How can I express that in the other notation? I can do real plus, don't forget the u, and then 0. Okay, so again, perfectly acceptable. What about my range? My range is given by y is equal to, so what's my lowest value? Once again, my lowest value is 0. I can get 0 out, so my lowest value is 0. And my highest value is actually infinity. Now I know it looks like this graph is actually going on to 4, but actually, theoretically speaking, this square root graph could go on and on and on to infinity and keep going. So my range is from 0 to infinity. Now I suppose you've been looking at wondering whether there was ever going to be a graph, and I'm just going to rub this little lines out here to make it a little bit clearer. I bet you were wondering if actually there were ever graphs where we had values that we couldn't use. Well, yes, indeed. Ladies and gentlemen, bringing that down just a little bit. There's the graph of y equals 1 on x. Look at the domain. I'm going to write my domain. So there's my domain, and it's x is in. So what does this mean? Look along the values. Look along the x values and tell me, is there a value of x you could not put into that graph? Well, actually, even if you don't look at the graph, look at the equation. You have the equation y is equal to 1 on x. What's the one number we cannot divide by because it throws our calculator, it melts, explodes, starts singing? And that is the number 0. Yes, we cannot put 0 into that equation because 1 divided by 0 is infinity, undefined, bang, crash, everything goes wrong. So actually, it would appear that all values could go into that equation except for 0. And so how do we write that? Well, we write r slash 0. All real values, but not 0. Now, if someone said today, could we write it in interval notation? I suppose you could. You'd have this. You'd have that. So from minus infinity to 0, or from 0 and to infinity. Notice that neither of these are square brackets, so it's not including 0 as my number. Generally speaking, I don't know that anyone would write it like that, but it's the way it goes. Now, what about my range? Can you see anywhere on here, is there a value of y that doesn't seem to be possible? And actually, as it turns out, once again, there is. Because if I was to rearrange the equation y equals 1 on x to x is equal to 1 on y, again, y cannot be 0. So our y value would again be all real, but not 0. And I could write that other notation if I wanted to. Now, a word of sort of pre-learning for what's coming up, and I can draw those dotted lines back in again. When on a graph, a value cannot exist for x or y, we call those asymptotes. So in this situation here, the graph of 1 over x has 2 asymptotes. That's going to come in really useful later on, I promise. Now, almost moving on to a couple of examples, but 2 more major things to know. Barry loves adding completely pointless words, and one of those is the word maximal. So you may see in an exam, what is the maximal domain of a function? Or what is the maximal domain for this equation? It just means domain. It just means if you were to draw that graph going on to infinity and beyond, what would its domain be? Later on in videos, we actually start limiting our domain. We actually start cutting down our domain. And so we actually say we've got a limited domain. A maximal domain just means the whole thing. Now, if you're looking at this at the moment, I'm going to zoom in for just a moment and going, yuck, that looks revolting. Hopefully you're not talking about me because that would be rude. But what hopefully you're looking at now is looking at this and going, well, that looks revolting, but hold on a moment. I think I can answer that. This is another way to write a function. It uses set notation. Why does it use set notation? Because firstly, we have these squiggly brackets. So let's deconstruct it bit by bit. What does this mean, this x comma y in front of the colon? Well, what it's now telling me is that my set is going to fill with coordinates. That's all it does. So this bit here says, I'm going to create a set filled with coordinates. It doesn't have to just be numbers. No one said it had to just be numbers. It could be coordinates. How do I create those coordinates? Well, to be able to create coordinates, I need a relation or a equation. There we go. So now what it's saying is, well, I want you to create coordinates that fit the relation y equals x squared plus 1. We can do that. But what values of x do you want us to use? Well, there we go. It's telling us here. It wants our values of x to be in our positive real numbers or 0. Now you've done that. Any question now could write this down and you could be going, hold on a moment. What do you want me to create? Coordinates. How do you want me to create them? Using this function. And what values do you want me to put in? Using this sort of domain. This stuff is amazing. All right, so here are some examples of how to find domains and ranges. So the following examples have been extracted with permission from the Cambridge Mathematical Methods Units 1 and 2 textbook. And thank you, Cambridge, for allowing me to do that. Greatly appreciate it. You guys rock. Awesome. So I'm just going to say here, what I've written in bold, I'm pretty sure half the lads out there who are reading this will completely disregard it. Sadly, you half are probably going to lose marks hand over fist. Don't skimp on drawing diagrams. Drawing diagrams is going to save you, and I'm going to show why. Okay, so the first one, for each of the following, complete the square, sketch the graph, and state the range. Important thing for the question says the domain is real. Fair enough. So first things first says complete the square. So we've got y is equal to x squared minus 4x plus 5. So completing the square gives me x minus 2 all squared 4 plus 1. Whoop whoop. Why do we complete the square? Well, we complete the square to give us our turning point or our minimum or our maximum or vertex. Call it what you will. That's what we actually do. So I now know I can draw this graph and I know it has a minimum at the point 2, 1. And fingers crossed it's going to do something like that. That was the shonkiest quadratic I have ever drawn in my entire life. Try that one again. There we go. So because my domain is real, it means that that graph goes on to infinity and beyond. I keep putting x values in, I can keep getting wider and wider and wider, and it will keep going on. My hand we're missing there. That was slightly awkward. Which one is missing? I've got to be careful of this one. What is my domain? They've already given me real, but what is my range? What are my values? Well, what's my lowest y value? Well, we work that out there as being 1. So now I know my range, which starts y with a little e sign. It starts at 1 and includes 1 and will go to infinity and beyond. Hopefully you didn't find that too difficult, but the reason we completed the square was to help us find that lowest value. But then maths, being a trick, really does try and throw a spanner in. I can guarantee you that in any exam you do, there will always be one of these questions, and I know it's in VCAR every single year. It tests your understanding. So, sketch the graph of the relation y equals x squared plus 2 for, hold on a moment, what's this guff? Well, that's telling you that it wants you to only do values of x from -2 to 1. Okay, so I'm not interested in this graph going on and on and on. It's from -2 to 1. So here we go. I'm going to draw my sketch. Problem is I don't know what values are. So what I'm going to do is I'm actually going to find the endpoints of my graph. I'm just going to find the endpoints of my graph. And by the way I do that is say, well, if I have y equals x squared plus 2, and I know that my first x value or my lowest x value is -2, then -2 squared is 4, plus 2 gives me 6. So I have a value as -2, 6. So I know that the top of my graph is there on the left-hand side. So that's the highest point it gets to on the left-hand side. I'm now going to put 1 in. So x is equal to 1. 1 squared is equal to 1 plus 2 gives me 3. And so when I put my value of 1 in, and this is wildly not to scale, I know that this highest point there comes out to be 3. So what is my range? Sadly, if you've said, I know this, it's between 3 and 6, you have had a massive trick. Because look at the shape of that. What do you know that is? It's a parabola. And I will guarantee you that actually the graph will go lower than those 2 points. And this is why it tests your understanding, because you've got to realize that it actually goes lower than the actual values there. Yes, you see what I'm saying? And so as a result, and in fact, we know the lowest point, because that was a really bad diagram, but we know the lowest point is actually going to be at the point 2. How do I know that? Because of this graph actually tells me that when I put that, or when I try and draw that, that's going to give me the lowest value. So my range is actually from 2 all the way up to 6. And you're going to say, hold on a moment, why is it up to 6? Remember, the range is the smallest y value that you've created up to the largest y value. The smallest y value is at the minimum. The largest y value is at 6. So you have to draw these. Lads, if you're out there and you're going, I don't want to draw them, you have to, or you're going to throw away unnecessary marks. This is the last example before I finish this video. And again, another reasonably long one, but very, very important. For each of the following relations, state the implied domain or range. There is only one. Do you know what that shape is? Well, generally speaking, hopefully you do, because if we have x squared plus y squared is equal to 9, then we know that that is actually a circle. Center the origin with a radius of 3. Yes, that's this one here, but that's not what we've got. We've obviously translated that circle 1 unit to the right. So I'm now going to translate this 1 unit to the right, and it's going to look something very badly like this. Now, why is this important to me? Because it wants the domain and the range. It's now asking you for the smallest values, or the values by which we can get x's, or it exists. Now, for a standard circle, my domain there would have been between -3 and 3. That's for my standard circle. What would my range be? My range would also have gone between -3 and 3. But we've shifted that circle 1 unit to the right. And as a result, does that change the height? Did that change my range at all? Nope. So my range is probably the easiest one to work out here, because I know it goes from -3 to 3, including, hence the square brackets. But what about my domain? Well, it was at -3, it's now going to go to -2. It was at 3, it's now going to go to 4, because we've moved it 1 to the right. And so my range is now -2 to 4. Again, drawing diagrams saved the day. It allowed me to visualize this and work out what I was doing. Right, ladies and gentlemen, thank you so much once again for watching. If you are about to press stop, please don't just listen to the last couple of minutes. It is really good having you here. Thank you. Hopefully you've learned. If you have, can you leave a comment below and just let me know what you thought of the video? Greatly appreciated. Over there is a circly doohickey thing that'll allow you to subscribe if you haven't already done so. And seriously, guys, so pleased if you can get a couple of your friends to do that as well. Otherwise, the video is loading below it, and I am done. This is MaffsGuru signing out. I look forward to seeing you next time. All right, have a good day. Take care. Bye-bye.